So math modeling with trig, with sinusoids, so these will all be sinusoid applications. So remember, sinusoids are those wavy graphs, sine and cosine graphs. They have our three dotted lines, a max and a min, and the graph keeps going back and forth between the max and the min. So we use trig, we use sine and cosine to model a lot of things in the real world where whatever's going on in the situation consistently and evenly goes back and forth between two values. It could be a pendulum, and you'll see that on, I think it's the first one on the worksheet that I gave out in class. And those of you at home need to print out the homework set, and there are two versions of it. What I handed out in class is on the long legal paper, and so some of you may have trouble getting your printers to print that. So I also did a version that I posted that is just for regular size paper, but it's 3 pages instead of just front and back, instead of just 2 pages. It's still the same 5 problems, just spread out differently. So you will need that. So it may be something that's swinging like a pendulum, and it goes from a farthest point on the left to the farthest point on the right. So if you imagine putting a number line down underneath it, the left would be a smaller number than the right, and those would be your min and your max. Might be positive and negative 5, or it might go from 2 to 15 or whatever, but a smaller number for the left side and a bigger number for the right. Some of them will be things like you see in the pictures in front of you. How many of you have seen one of those either on your travels, some boat on a river somewhere, or in a museum, or in a movie? You've seen the steamboats powered by the paddle wheels. The whole idea on those is you have a wheel that goes round and round, and the wheel has a whole bunch of little paddles on it. So this one here on the left, it's going like into the screen, so this is the back of the boat here. So the wheel is turning in a clockwise direction as I look at it from this angle. So when these little paddles get down to the water, they start pushing against the water to push the boat forward. And then that paddle gets back here and it comes up, and it's not really doing anything while it's up in the air to help the boat go forward, but other paddles are taking their turn to help the boat go forward. So everybody got the basic idea of what's happening now. Okay, we're going to imagine now it's going the other direction. Now it's going to the left, so the wheel's now spinning counterclockwise. Imagine that we take some green paint and put a dot on just one of the paddles, floats out of the water, and then we let it dry. And then the boat starts going. And we look at where that green dot is relative to the surface of the water at any given time. So if I put it where you see this green dot in this picture, it starts out up above the water, and then the wheel's going to turn, so my green dot gets a little bit higher above the water, and then it starts coming down closer to the water, and then it just touches the top of the water, and then it goes down underwater for a little bit, and then it comes back up. So that green dot is going to go back and forth from a low being somewhere below the surface of the water to a high being however far it is above the water when it's at the top of that wheel. So does that make sense? And you see how that goes back and forth between a couple of values. Okay, let's do our first application problem where we have one of these going on. So we've got a water wheel. It may be on a boat, or it may be one of those ones like up at Idaho Springs by the side of the mountain. And then they start telling us some stuff about this problem. And so we just start reading and seeing, well, how does that help us? We draw pictures, we write things down as we read it. Well, what do we know? What does that mean? So it goes around 6 times every minute. So that's talking about going back and forth and doing complete cycles. If it does 6 cycles in 1 minute, how long does it take to do just 1 cycle? Because that's going to be the period, Liam. So that means our period needs to be 10 seconds. That's a point on our sinusoid. Most of these, your horizontal axis is the same, but the 29 that we need to go back to, sometimes it's horizontal difference, or distance, and vertical distance. There'll always be time, but that's what you'll have most often for that horizontal axis. So since I know at 2 seconds, I'm going to do a dot for that. It's a max, and then it comes to a center, and then it hits the min, and then it comes to the center, and then it's back to a max. And I know that is a complete period. But I know that my period is 10 seconds. So if I'm at a max at 2, 10 seconds later, I'm at 12. And I could, if I wanted to, figure out that min is halfway in between, so it's at 7. But I may or may not put that on there. So far, so good. We started off with a point that we know. The basic shape of the sinusoid. Is there something else that we know? Okay, let's see what else we can come up with. I know that the radius is 7 feet. And they tell me that from the center to the surface of the water is 6. Well, that's almost a radius, right? But I've got another 1 down here below the surface of the water. So if I want to let the that means my min has to be 1 foot below the surface of the water. Does that make sense to everybody? And if I then go all the way up to the top, it has to be 14 for a diameter, and 14 above the -1 would be 13 for the max. And who can tell me what my center line would have to be? What was that? It would have to be 6. It would have to be the 7 above the -1, the 7 below the 13. Hey, wait a minute. That means I can start to write an equation for this. I'm starting to know enough I have to be able to write it. So, I have to be a little bit careful here. They tell me what variables I need to use. They tell me that they want me to use D for that vertical distance above the water. And they want me to use C for the second step. So that can be the I equation. D equals. If I know coordinates on a max, which is easier, plus or minus, sine or cosine. When you know a max to start out with. Ava? Cosine and plus or minus? Plus. Because we know a max, it is easiest to do plus cosine. We know we have a period change, so I'll deal with that number in a minute. But I also know that I have a shift. Since I went 2 to the right for that max, I know I need a t minus 2 right there. So far, so good? Now, one thing that's going to be important on these, use radians, which means we're going to need to adjust our calculators, but these are much easier if we do them in radians and not degrees on these problems. So what's a normal period in radians, everybody? A normal period is 2 pi, and I know for this one my period is 10 seconds, so that means my number in the equation needs to be that normal 2 pi over 10, or pi over 5. So that's my equation. It asked me to model it. This is my model using the letters they told me to use. Now when I put it in on the calculator, I'm going to have to switch to F1 of X and X in there for the calculator's sake, but that's easy to do. The other thing you're going to need to do on your calculator is put a second set of parentheses in there. Or it's going to think that it's just the cosine of pi over 5, and then you're multiplying that value times the t minus 2 or something. So just to make it work out. Okay, let's see what else this thing says then. Okay, so here's another copy of our same sinusoid, -1 up to 13. At time 2, we're at a max. When you draw these, you do always want to put a dot on whatever a critical point is for that problem, one you know or something you're trying to find, so that we see what you're looking at on the graph. This wants us to find when we first emerge from below the water. What does the word emerge mean? So, see some people pointing like this. It's been underwater and it's coming up. So, would this point right here be where it's been below the water and it's coming up? No, that's where it's above the water and it's going down. So that one is not what we want. What we want is probably this point. So we're going to need our calculator to help us. We need to put the sinusoid in so we can see it on the calculator. And then we want to know, now for this particular one, that's where the sinusoid crosses the x-axis. What kind of point is that when it crosses the x-axis? Levi? Anytime a graph crosses the x-axis, what do we call it? Whether it's a parabola or whatever. The x-intercept. But what does the calculator call x-intercepts? Zeros. So we're going to need to find a zero there. Sometimes we're going to need to find an intersection point. Sometimes we're going to need to find a max. Kind of like all those parabola application problems last year. Depends on what the problem asks. So we need to go to our calculators now. And we need to fix our settings. And we're going to do these in a document, not on the graphing page of the scratch pad. It'll just be easier for other things we're going to be trying to do in there if we do it that way. So a couple of things we can do, and maybe a good idea to do it both ways. We can go to, it always does that to me. So, where did I just hit for that? All right, so we can go on the home screen, settings, document settings, and be sure this says Radians, and make sure while you're at it that it says float. And if your version still says make default and okay like mine, make it your default and then okay. You'll have to change it back when you do some other problems on problem sets, but go ahead and change that. And then we are going to create a new document. So you can go to new document. I've already got mine in there, so I'm going to just hit recent maybe. if it decides it's going to work. And why does it not want to cooperate? Maybe that's why. I have no idea what. And you're going to enter our equation that we had written down. And let's see if I can get it where we can see that. On here. So this equation that we wrote down that you see at the top of the screen, except f1 of x instead of d equals 6 plus 7 cosine, and then we're going to have that double parentheses, pi over 5, and then the second parentheses start, and x, not t, minus 2. And then enter. And hopefully you see something like you kind of see on mine that looks like, oh, well, there's a sinusoid in there somewhere, but I need to fix it on mine so I can see the whole sinusoid. If you think about our graph, we know that the y's need to go from negative 1 up to 13. And let me get rid of that for a moment. We know that the x's, well, we want them to go out at least to 12, so we've got a complete period showing up in there. So what I need to do on my calculator is menu. Why does it keep doing that? So menu, window zoom, so I can fix those settings, and we're going to pick choice number 1. I want my x's, well, the negative 10 was fine, but I'd kind of like it to go out at least to that 12, so I don't know, 20. Anything you like that's bigger than 12. My y's, that negative 6 was fine, but I need my y's to go up at least to that 13, so maybe I'll put 20 in again. So we just think about our graph. And what do we need the x's and the y's to go to? Then we said I want this point right here where it's a 0. Notice I can also look at that. The other place where it would have been coming up from the minimum would be negative time, and that makes no sense in a problem. So I definitely don't want this. Sometimes I might have had one over here if my given point had been this one out here for some reason. So we look at the graph. This is what we want. Menu, analyze graph. We said it's a 0, so that first choice. Line to the left of the one we want and to the right. And it tells us 7.861 seconds to answer that problem. Anybody having trouble getting that on your calculators? A question about what you need to do? Everybody good with that much? So then I could go back to my problem, maybe, and say, what did I say, 7.861? And does that make sense when you look at it? We knew 2 and 12, but halfway in between would have been 7. Does it make sense that we got something a little more than 7, but less than 12? So you can look at your graphs and see if it makes sense. All right, let's do 29 off of that problem set. Got up here as a reminder, use radians. If you didn't hear me, use radians. Whenever you do these problems, use radians for your period and as you're entering things on your calculator. You start off, you plot whatever points you know. It may be a max, it may be a center, it may be a min, it may be the y-intercept. intersect, whatever you know, plot. Draw in your sinusoid that goes through there, and decide based on what you know coordinates for, is it going to be easier to do it with plus or minus sine or cosine? So 29. So this one is talking horizontal distance that the car is driving, and vertical distance as pebble gets stuck in the tire tread as the tire goes over it. So when it first gets stuck, the pebble's on the ground because the tire's going over it. And then the wheel turns and the pebble stays stuck, and so it goes and makes it up to the top of the tire, and then starts coming down, and then touches the ground again, but it still stays stuck in the tire tread, and then it goes up, and then it goes down. So for this one, when we draw our graph, we're going to have our horizontal distance, and we're going to have our vertical distance. We know that it's going to start out on the ground, so 0 inches up above the ground. So we know the min is that horizontal axis. And then we know we're going to have a center line and an max. Who can tell me the highest that it ever gets up above the ground? If the highest that it's ever going to get is 24 inches, because that's the diameter of the tire. So this is 24, which means this is 12. So right now we know, and let's see, this doesn't tell us what we have to use for letters, so I'm going to let this be X and this be Y, so I don't have to worry about changing, because it just says come up with an equation. So my equation is going to be y equals center line 12, and depending on what curve I end up using, either plus or minus 12 cosine px plus or minus a shift. Okay, so let's see what else we know. When we've gone from that point where we roll over the tire, we know we start at 0, 0. Because that's where the pebble first gets stuck in there. So we know that our graph is going to look like that, and we draw at least one complete period in there. So, what point do I already know? 0, 0. So should I use plus or minus sine or cosine? What's going to be easier? Well, positive sign would mean I want to know a center line increasing. So negative cosine. Everybody good with that? So let's make this be a minus cosine. Now we don't have to do a shift. So I'm just going to have x, not x minus anything. All I got to figure out is the period change. And what number do I put in there for the period? Okay, now, horizontal distance. The diameter is 12. As it rolls around once. Formula for the circumference is pi d, and if d is 24, that means 24 pi. That is my period. That's how long it takes to go through the cycle once. That means my number in the equation needs to be my normal 2 pi over the period on the graph, which is 24 pi, or 1/12. So I can either write that as 1/12 x, or just x over 12. Might be a little bit easier when we're ready to enter it on the calculator. So this time, let's do a new page on the calculator document. Let's not get rid of that. Let's just do a new page. We know we're still in radians. Let's enter that in there. And let's think about the window. The y's need to go at least from 0 to 24. The x's need to go, let's see, 24 times pi. 24 times 3 is 72, so I need something bigger than that, because it's 3.14, etc. So maybe I'll go to 100 when I enter that. So let me get mine up here, and I will try to enter that on mine as well. Better do it over here since it's not liking me to touch it. I'm going to do a new page, which is another graphing page, and I'll enter 12 minus 12 cosine, and then I need x over 12. Enter that. And okay, it's kind of looking like that, but I'd like to see more of the sinusoid. At least it's looking like it's curving. So, menu, window zoom, settings. I said, that's fine, but I'll let my x's go all the way to 100, and my y's need to go bigger than 6 2/3. They needed to go up to, what did I say, at least 24, so I'll put in 30. And now I can see at least one complete cycle in that. So far, so good. Okay, what else were we supposed to find on this problem? So we've got our graph, we've got our equation. If we go 15 inches, so that's going this way to the right. That's my x. So if x needs to be 15, how do I get y? If I want to know what y is, let's plug 15 in for x. Now, I can retype all of that and put a 15 in. Anybody have an idea of a shorter, easier way? Let me go back to my calculator. F2 was that, right? What if I do a calculator page now, and I pick variable? This graph is F2. My first graph was F1, so what if I pick F2 and just put a 15 in there? A little easier than retyping that whole equation, right? So that means that I could say for this one that it is 8.216 inches. Everybody good there? Okay, the other thing that you were asked on this one, the two distances when the pebble is 11 inches above the pavement. Is that a 0 like before? Is 11 the max or the min or anything? Right now it's not showing up on my graph. So I need to add another line to my graph. At 11. So it's going to be just a little bit below the 12. So I'm going to add that line in on my graph. And label that that is at 11. And then I want to find the two distances when the pebble's there. So I'm going to put a dot here and here. Those are the 2 points I'm going to try to find on my calculator. So back to the calculator, back to my graph that I already have in there. So I'll go back to that page. Now I'm going to tab to add that other line, which is easy, just equal to 11. And then what do I have the calculator do to get each of these points? It's not a 0. What am I looking for this time around? Okay. So this time it's intersection, so menu, analyze graph, intersection, and so lower bound, so I go to the left of the first one and the right of the second one, and get 17.8 848 inches. And then I do it again, menu, analyze graph, intersection, left and right of that, and I get the 57.550 inches. Does that make sense to everybody? Anybody at home with questions?